So today we are going to take notes on in the book, what is section 5.1 and 5.2. So we're starting our section on trigonometric functions with the unit circle and special right triangles. So quick reminder, two special right triangles. We have the 30, 60, 90 right triangle. So 60, 30, and we have the 45, 45, 90 right triangle. So if I make the hypotenuse equal to 1, then the short side of the 30, 60, 90 is 1/2, and the long side is the square root of 3/2. Likewise, for the 45, 45, 90, if I make the hypotenuse 1, then the two sides are congruent because it's also isosceles, and their lengths are the square root of 2/2. We can use these triangles to build up the first quadrant of the unit circle. I'm going to do this really fast because you definitely did this last year. So quick review. So if we start in quadrant 1, so I'm starting here. So this is the angle 0. So this is the angle 0 in degrees and 0 in radians. And the x, y coordinates are x, y. Are the two sides of a triangle when we start at the point at the end of the radius on the unit circle and we drop a perpendicular to the x-axis. See how I made a right triangle there? So here's the right triangle, and the hypotenuse is the radius of the circle. It's called a unit circle because the radius of the unit circle is 1 unit. So the radius is 1. So this triangle is the one where we have a 30-degree angle right here. So this is a 30-degree angle, and 30 degrees is also pi over 6 radians. I'm going to do this triangle, and then we'll fill in this a little bit. So since the radius is 1, that's the hypotenuse of the triangle, and this is the long side, and this is the short side, this point is the horizontal side is the x-coordinate, and the vertical side is the y-coordinate. So this side is the long leg, so the square root of 3/2. And this is the short leg of the 30, 60 triangle, so that's 1/2. Forgot to fill in the coordinates here. So at this point right here, when the angle is 0, the x-coordinate is 0, and the x-coordinate is 1, silly. The x-coordinate is 1 because that's the radius, and the y-coordinate is 0. Quick reminder, SOHCAHTOA, sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of an angle is equal to opposite over adjacent. So let me look at this one, for example. If I do this angle, 30 degrees, which is the same as pi over 6 radians, and I'm interested in the sine of the angle, the sine is opposite over hypotenuse, so opposite over hypotenuse. So the height over the hypotenuse, which is 1. So the sine of this angle is the height, which is I said sine. The height, which is 1/2. So this is the sine of the angle. And then cosine is adjacent over hypotenuse. So if we're looking at this angle, the adjacent is this side. The long side, square root of 3/2, divided by the hypotenuse, which is 1. So this is cosine. That's always going to be true. So the coordinates of the point are cosine of the angle, comma, sine of the angle. That's always true. let's go back over here and fill in some special right angles. So if we go half of the way around the circle in degrees, a full circle is 360, half of a circle is 180. If we go halfway between 0 and 180, that's 90 degrees. You can clearly see that this is a right angle, so that makes sense. Halfway between 0 and 90 is half of 90, which is 45 degrees. And then thirds of the 90-degree angle are our other special angles. So 1/3 of 90 is 30 degrees, and 2/3 of 90 is 60 degrees. So those are our other special angles. And now let's look at some of these angles in radians. So radians are multiples of pi. All the way around the circle in radians is 2 pi. So half of 2 pi is pi. And if I want to get this special angle, half of pi would get me there. So that would be pi over 2. I'm just doing angles. And I'm going to work on the first quadrant here just for the angles in radians. So half of pi over 2 would get me the 45-degree angle. So that would be pi over 2 divided by 2, which is pi over 4. And then I want to get these other special angles in radians as well. So this is 1/3 of the way from 0 to pi over 2. So 1/3 times pi over 2 is pi over 6. And then this is 2/3 of the way to pi over 2. So 2/3 times pi over 2 is pi over 3. So that gives me the special angles in the first quadrant in radians. So now let's quick fill in the rest of the values over here. So I filled in, I'm going to just quick copy these. So in degrees, this is the 30-degree, 45, 60, 90. And in radians, we have 0 radians, pi over 6 radians, pi over 4 radians, and pi over 3 radians, and then this is pi over 2 radians. So let's look at the other multiple of pi over 6 here. So the other 30, 60, 90 triangle. So if I drop a perpendicular here, we're only doing this one time, and then from now on, we're going to remember what they are and not reproduce them again. So this is also a 30, 60 degree angle, 30, 60, 90 triangle. So this green triangle is the same as the pink triangle, it's just facing the other way. It's a circle of radius 1, so the hypotenuse is 1. And this is the short side, long side, so the x coordinate, so the cosine is the short side, and the short side is 1/2. So the cosine of pi over 3 is 1/2. And then the y value, the height of that point, is the long side of the special right triangle, so the square root of 3 over 2. So that's sine of the angle. So now let's go in between and find the coordinates of pi over 4, which is 45 degrees. So that triangle is the 45, 45, 90 triangle. So if I drop a perpendicular from the point to the x-axis again, that's a right angle. This becomes my 45, 45, 90 triangle. The hypotenuse is 1 again. So the hypotenuse is 1, and both of the legs are square root of 2 over 2. So this x coordinate is one of the legs and the y coordinate is the other. So they are both the same, the square root of 2 over 2, the square root of 2 over 2. And then lastly, we're going to fill in the cosine, sine, so xy coordinates of this point here when the angle theta is 90 degrees, which is the same as pi over 2 radians. So we're not moving left or right. So the x or cosine coordinate is 0, and the height y is 1 because the radius is 1. So cosine of pi over 2 equals 0, and sine of pi over 2 equals 1. I'm going to fill in the angles speedy quick in radians here. You can work out what they are in degrees. And then we're going to talk about how to find the rest of the angles. So speedy quick, I'm going to tell you how I think about it in case it helps, but regardless, you need to remember these. I'm going to get the multiples of pi over 2 first. So every time we go 90 degrees, we're going a multiple of pi over 2. So I'm just going to talk in radians. So if I go, this angle is pi over 2. The same angle again is 2 pi over 2, which simplifies to pi. And then the same angle again is 3 pi over 2. So this is 3 pi over 2. And then another pi over 2, so that's 4 pi over 2, which simplifies to 2 pi. Fabulous. Now let's get the multiples of pi over 4. So this is 1 pi over 4. Same distance again, 2 pi over 4, which simplifies. 3 pi over 4, so this one's 3 pi over 4. 4 pi over 4 simplifies to pi. 5 pi over 4. 6 pi over 4, that simplifies. And 7 pi over 4. Now let's do the multiples of pi over 3. So this is 1 pi over 3. And notice that pi over 3 is obviously twice pi over 6. So like every other sixth of pi. So 1 pi over 3. 1, 2, 2 pi over 3. 1, 2, 3 pi over 3 simplifies. 1, 2, 4 pi over 3. 1, 2, 5 pi over 3. 1, 2, 6 pi over 3, which simplifies. Fabulous, that worked out. Now we only have the multiples of pi over 6 that we didn't already get with pi over 3. So this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Notice all of those were simplifying. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, which simplifies. We got them all. That's fabulous. Now let's talk about how to build out the x, y, or cosine sine coordinates of all of the points along the entire perimeter of special angles of the unit circle. So we get the same angles over again. We're going to talk about this in more detail later, but we're going to get a repeat of all of these coordinates over and over again. You just have to think about whether the signs are positive or negative. So in quadrant 1, x is positive, y is positive. In quadrant 2, x is negative, y is positive. In quadrant 3, x is negative, y is negative. Very important to remember this. And in quadrant 4, x is positive, y is negative. All right, let's get some quick definitions here. I'm going to dump these right on here to save myself some writing. I'm just going to talk about them. So I also added one. Notice I added initial side here. So the reference angle is the acute, that means less than 90 degrees, angle between the x-axis and the terminal side of the angle. Well, we better know what the terminal side of the angle is. So let's start with the initial side of the angle. The initial side of the angle is the side of the angle between 0, 0 and 1, 0. So that's always this. This is the initial side. This is the initial side of the angle right there. And then we build an angle going counterclockwise. So if I went here, this is my blank one, not my filled in one, but that would be pi over 3. So this would be the terminal side of the angle pi over 3. So the terminal side is the other side of the angle. So if we start at this angle and we rotate ourselves, whatever our angle is, then that other side is the terminal side. Definition: coterminal angles. Two angles that share a terminal side are called coterminal. For example, if we had the angle pi over 4, so this is the angle pi over 4. Angles go counterclockwise. But if I went negative 5 pi over 4, I would start at the same initial side and go the opposite way, so clockwise. Negative 5 pi over 4, so I would count negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4. So clearly I wrote the wrong one. All right. And those are coterminal. And lastly, the terminal point, it's the xy pair on the surface of the unit circle and the terminal side of the angle. So for example, pick any angle. So let's say I chose pi over 4. I'm interested in the terminal point for the angle pi over 4. So we built that one out already. So this is where the terminal side of the angle pi over 4 is. The terminal point is square root of 2 over 2, comma square root of 2 over 2. So that is the terminal point. So now I'm going to turn the page. And we're going to talk again more about these trig values. Super quick, you already know. We already talked about this mnemonic, SOHCAHTOA. So you can remember the relationship between the sides of a right triangle and the trig function. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And it's important to remember that tangent is also equal to sine over cosine. Reciprocals, again, you should remember these. The reciprocal of sine is cosecant. So cosecant is equal to 1 over sine of the angle, and vice versa. The reciprocal of cosecant is 1 over sine. So the reciprocal of cosine is secant. That means secant is equal to 1 over cosine of an angle. Cotangent is the reciprocal of tangent. So it would be the same as 1 over tangent of the angle. And it's also the reciprocal of sine over cosine. So that would mean it would be equal to cosine theta over sine theta. One way to evaluate trig functions is the following. There are other ways as well. Some people memorize the entire unit circle, that's fine too, but because we absolutely need to have a common vocabulary, you definitely need to be able to find the reference angle and use it. So what is a reference angle? So remember that we just talked about that, it's speedy fast. And the reference angle is the acute angle between the x-axis and the terminal side of the angle. So good thing we wrote that down. Then we determine the sign of the trig function in the quadrant that we're in, positive or negative, and then we find the value. So the first thing we're going to do is figure out where 5 pi over 6 is. So I'm going to do my speedy quick unit circle. So I'm going to count by multiples of pi over 6. And I'm remembering that this is pi, and then all the way is 2 pi. So if I count multiplies of pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, this was 5 pi over 6 right here. So there's my terminal side. That's my angle. But what's my reference angle? This is my reference angle between the terminal side and the x-axis. So right there, that's my reference angle. So it's not where that angle is. It's not like, what's the angle from there? It's how big is that angle? So that reference angle, the size of it is pi over 6. So the reference angle is pi over 6. So we can find the xy coordinates for the angle pi over 6. So we should have them memorized, but we're just talking about it right now. So let's look back at what we drew out. And when we were building this just a few minutes ago, the coordinates of the angle pi over 6 are square root of 3 over 2, 1/2. So these are going to be the same square root of 3 over 2, comma 1/2 for the angle 5 pi over 6. It's just potentially the signs plus minus that are going to be different. So what are the signs of the x and y or cosine sign in quadrant 2? And they are negative, positive. That means this one's going to be negative and that one's going to be positive. So we found the terminal point. That means the coordinates of the point on the surface of the unit circle for the angle 5 pi over 6. All right, we're going to do the same thing for 7 pi over 4. So I'm going to draw my speedy, quick little unit circle, and I'm going to count by multiples of pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So that's here. So this angle is 7 pi over 4. The acute angle between the terminal side and the x-axis is this one right here, and the size of that angle is pi over 4. So the reference, that's an R, angle is pi over 4. And the coordinates for the terminal point when the angle is pi over 4 is square root of 2 over 2, square root of 2 over 2. And what are the signs in quadrant 4? Positive, negative. So this one's positive and this one's negative. So those are the coordinates of the terminal point. All right, we're going to keep going. So for letter C, another super quick unit circle. Remember, negative angles start at 0 and go clockwise. So we're going this way, and we're going to count by multiples of pi over 3. So this is 1 pi over 3, 2 pi over 3. So right here. So this is negative 2 pi over 3. How big is this angle between the terminal side and the x-axis? It's this one right here. The size of that, the reference angle, is a size pi over 3. That's what matters. And what are the coordinates of the terminal point for pi over 3? They're 1/2 square root of 3 over 2. And then what are the signs in quadrant 3? In quadrant 3, we go left, so that's negative, down, so that's negative, so negative, negative. So they're both negative. Same thing for this angle, but once around the circle is 2 pi. So 29 pi over 6 definitely goes around the circle more than once. So once around the circle is 2 pi. So if I can subtract multiples of 2 pi until I get to an angle that's less than 2 pi, I'll be able to determine where, in what quadrant is this angle. So I want a common denominator so it's easier to figure this out. So the common denominator is 6. So 2 pi, if I multiply it by 6 over 6, is the same as 12 pi over 6. So what are the multiples of 12 pi over 6? They are 12 pi over 6 and 2 times 12 pi over 6. So that's 24 pi over 6. That's big enough, but actually, that's big enough. If I go bigger than that, I'm going to get bigger than 29 pi over 6, and I don't want to end up with a negative angle. That's not helpful. So coterminal, meaning having the same terminal side angle. I'm going to take 29 pi over 6 and subtract 12 pi over 6. That will have taken me 2 times around the circle, so I should lay it in the same place. Oops. And we did this angle already, so we already know the coordinates, so we don't need to do it again. So the coordinates of the terminal point are negative square root of 3 over 2. Positive 1/2. So that's nice. All right, different kind of example. So now we want to find the 6 trig values for the given angle. So for practice, sine, cosine, tangent, secant, cosecant, cotangent. This angle is in quadrant 1, so we should have that one memorized. So that's this angle here, pi over 3. So let's see, let's do sine, cosine, tangent, and then I'll write the reciprocals over here. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. So the height of this, or I have these memorized, is the square root of 3 over 2. Cosine of pi over 3 is 1/2. And tangent is sine over cosine, so that would be the square root of 3 over 2 divided by 1/2, which is the same as times 2, so that simplifies to the square root of 3. And then we'll do reciprocals. So the reciprocal of square root of 3 over 2 is 2 over the square root of 3, and then multiply by the square root of 3 over 3, so that would be 2 square root of 3 over 3. The reciprocal of 1/2 is 2 over 1, so 2. The reciprocal of cosine, so I can take the reciprocal of this, which is 1 over the square root of 3, rationalize by multiplying by the square root of 3 over 3, and I get the square root of 3 over 3. Now let's work on this problem. Another angle. So let's figure out where that angle is. Pi over 2, 1 pi over 2, 2 pi, so it's right here. So that's the 90-degree angle. I like to think of them in radians though. So that's pi over 2. So what are the coordinates of that point? I'm not going left, right from the origin. I am going up 1. So the coordinates of that point, I'm going to write down the coordinates of that point, are 0, 1. All right, so make my same list. Sine, cosine, tangent, cosine, sine, cosine. Tangent is sine over cosine, so that's undefined. The reciprocal of sine is cosecant, which is 1 over 1, which is 1. Reciprocal of cosine is secant, so that would be 0 over 1, so 1 over 0, so that's undefined. And the reciprocal of 1 over 0 is 0 over 1. I didn't write down what this was. This was cotangent. So reciprocal of this is 0 over 1, which is 0. So we did that one. All right, so why don't you take a minute and find all of these 3, pause the video, work it out, and then I will put up the answers for you to check. So hopefully this is what you got. That's a negative sign, a little hard to read. For this one, you ended up needing to subtract 16 pi over 4. That was a multiple of 2 pi that got you to the coterminal angle for this one, which was 3 pi over 4. All right, let's look at these. This is just calculator practice. So we'll do one together and then you can pause to check your answers. Notice the angles are the argument of sine, cosine, cotangent, and so forth. So these are all angles and none of them have a degree symbol, which means you have to be in radian mode for these because none of the angles are written in degrees. So let me just remind you where this is. If you click the mode button, you have all these options, arrow down and make sure radian is highlighted. And then sine of 2.2, you just hit the sine button, type in 2.2, and you get an answer. And we're going to round to 3 decimal places as the AP wants us to. So this is 0.808. you're going to have to use a reciprocal function for cotangent and cosecant because you don't have a cotangent or cosecant button. You only have sine, cosine, cosecant. So, sorry, sine, cosine, tangent. So pause the video and then check your answers. All right, take a minute to check your answers, and then let's move on to the last page. So remember even and odd functions. We're going to find the even and odd function properties for trig functions. So we're going to draw a little diagram, work it out from scratch, and then after this, we're going to remember these facts. So if I put a random angle, not a special angle, right here, and I call it theta, then the coordinates of the terminal point are cosine theta, sine theta. And let's label these, color code them. So the x coordinate of the right triangle is the cosine value, and the y coordinate of the terminal point is the height or the vertical side of the right triangle. So if I put an angle that has the same measure, same size, but going in the opposite direction, so negative theta, these angles are the same size, it's down here, and this has coordinates. But the size of the sides are the same because it's the same triangle, it's just in a different place. Okay, so this is the vertical side, and the green is still the horizontal side, but the pinks are the same size, and the green is literally the same everything. So the cosine of this angle down here, the x-coordinate, is exactly cosine of theta. The pink, the y-coordinate of this angle, negative theta, same length, but it went the opposite direction, so it's negative sine of theta. All right, look at that. We've got even and odd properties. So let's write down some of our even properties. Even. So if we take cosine of negative theta, cosine of negative theta, whoops, these were both negative theta because we took negative theta. These are both negative, right? I did negative theta. So cosine of negative theta is the same as cosine of theta. So it's equal to cosine of theta. That's what it means if a function is an even function. Sine is not even, I get the opposite sign. But some other things are even. So cosine and secant are reciprocal, so they're going to have the same property. So secant of negative theta equals secant of theta. We have one that has an odd property. So notice that sine of negative theta. So this is sine of negative theta. The length is the same, but the sign is opposite sine of theta. So it's equal to negative sine of theta. That's an odd property. And the reciprocal of sine will also have that property, so cosecant of negative theta is also equal to negative cosecant of negative theta. And then what about tangent? So tangent of theta is equal to sine of theta over cosine of theta. This is not even. We're just working it out. So tangent of negative theta is equal to negative sine theta over positive cosine, sorry, of negative theta. So yeah, positive the angle, sorry. So it will be equal to negative sine of theta over positive cosine of theta, which is equal to negative over positive negative. So negative tangent of theta. So that's odd. So tangent of negative theta is equal to negative tangent of theta. So that's odd. So we're going to remember that now. So let's use these properties to evaluate these functions. So we could find this a different way, but we're going to use the property. So sine is an odd function, so sine of a negative angle equals sine of the positive angle. So this would equal sine of positive pi over 6. That's the odd property. And what is sine of pi over 6? It's 1/2. So because it's opposite of that, oh, look, I wrote it down wrong. Negative. So it's negative 1/2. All right, we're going to do the same thing for cosine. So cosine is an even function, so cosine of the negative angle is the same as cosine of the positive of the angle. What's cosine of pi over 4? It's the square root of 2 over 2. So cosine of negative pi over 4 is also square root of 2 over 2. All right, now we're going to work out the Pythagorean identities. So let's look at a same random hypothetical angle on the unit circle. Drop a perpendicular, draw a right angle. The x-coordinate is cosine of theta, the y-coordinate is sine of theta, and the hypotenuse is 1 because it's the unit circle, so the radius is 1. So I can say using the Pythagorean theorem that side squared plus side squared equals hypotenuse squared. So cosine squared plus sine squared equals 1 squared, which is 1. So that's one of the Pythagorean identities. And then we can get 2 more just by doing some simple algebra. So if I divide both sides by cosine squared, I get cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. And 1 divided by cosine squared is secant squared. So that's a Pythagorean identity. And if I do the same thing and I divide my original by sine squared theta, so cosine squared over sine squared is cotangent squared. Sine squared divided by sine squared is 1. 1 divided by sine squared is cosecant squared. And that's my third Pythagorean identity. So we're going to use one of these Pythagorean identities to answer this question. So we have cosine of an angle, we know it's in quadrant 4, and we want to find all 6 trig functions of that angle. So remember that we're in quadrant 4, and the signs in quadrant 4 are positive, negative. So first, let's use the Pythagorean identity that has cosine squared to find the value of sine. So cosine squared, so 3/5 squared plus sine squared is the thing I don't know, equals 1. So sine squared equals 1 minus the squared is 9 over 25, which is 16 over 25. Take the square root of both sides, sine theta equals, we took the square root of a square, so it's going to be plus or minus. Square root of 16 is 4. Square root of 25 is 5. Now, how do we know whether it's positive or negative? Well, we're in quadrant 4, so cosine is positive and sine is negative, so it's going to be negative. So sine of theta is negative 4/3. We already knew what cosine of theta was because that was given. Tangent of theta is sine over cosine, so that would be negative 4/3 divided by 5, 3/5, so that would be times 5 over 3. Okay, I found my mistake. That was a 5, and I accidentally wrote it as a 3 because I couldn't read my own handwriting. Okay, that's better. So tangent is sine, which is -4/5, divided by cosine, which is 5/3. Cross simplify, so tangent is -4/3. Reciprocal identities. So reciprocal of sine is cosecant. So that would be -5/4. Reciprocal of cosine is secant. So reciprocal of this is 5/3. And reciprocal of tangent is cotangent, and that's -3/4. Last problem. We're going to write tangent in terms of cosine, and we're in quadrant 3. So let's pick our Pythagorean identity that has the ability to relate tangent to cosine. So I have tangent here, and it doesn't have a cosine, but my other trig identities with cosine don't have tangent, and I want to solve for tangent, but secant is the reciprocal of cosine, so I'm going to use this one. So 1 plus tangent squared theta equals secant squared, which is the same as 1 over cosine. So it's going to be 1 over cosine squared. So I have an equation that has the expressions that I want in it, and I want to solve for tangent. So we'll subtract 1. So tangent squared is equal to 1 over cosine squared theta minus 1. And then take the square root of both sides. So tangent theta equals plus or minus the square root, because I took the square root of a square. Now we're not trying to find a number value, so we're going to have this expression under the radical, and that's fine. So we just have to figure out whether this sign is positive or negative, and then we're done. So we're in quadrant 3, 1, 2, 3. So the coordinates are negative, negative, so that's cosine sine, but tangent is sine over cosine, so negative divided by negative is positive. So we're going to take the positive answer. So the answer is tangent of theta is positive, and then this big square root, 1 over cosine squared theta minus 1. Good job, everybody.